We have spent a considerable amount of time in calculus talking about limits, trying to find limits of functions, and we've also encountered a number of things whose limit it's difficult to find algebraically. So an example of this might be the limit as x goes to 0 of the sine of x over x. And if we attempted to solve this by substitution, we would end up with the sine of 0 over 0, which is immediately a problem, and more specifically, the sine of 0 is 0. So we've been stuck up to this point. Now this 0 over 0 is one of 6 what are called indeterminate forms, which simply mean if I'm attempting to find the limit and I simplify down to 0 over 0, I simply cannot determine what the limit is. Now, L'Hopital's rule, though, allows me to deal with this. In general, the rule says that if I'm taking the limit as x approaches some value a of f of x over g of x, right? So I need to picture whatever I'm thinking about as a composite function. Then this will be equivalent to the limit as x approaches a of the derivative of the numerator over the derivative of the denominator. And so this is the rule, and anytime I encounter an indeterminate form, one thing we can do to move forward is simply apply L'Hopital's rule. So back to our context, the limit as x approaches 0 of the sine of x over x must be equal to the limit as x approaches 0 of the derivative of sine of x, which is cosine x, over the derivative of x, which is 1. And this is a much nicer form. If I substitute in 0, I end up with 1 over 1, which is 1. That is the limit of my function. The indeterminate forms are 0 over 0, infinity over infinity, infinity minus infinity, 0 times infinity, 0 to the 0 power, infinity to the 0 power, and 1 to the infinite power. So if you're dealing with a limit and you arrive at one of these forms, this is an indicator that should try to approach this using L'Hopital. Sometimes this takes some ingenuity, or just recognizing what it is that we are dealing with. Here's another example. We'll deal with the limit as x approaches infinity of x times the sine of 1 over x. And by substitution, we're going to get infinity times the sine of 1 over infinity which is infinity times 0. Right, 1 divided by infinity, as x goes to infinity, 1 over x goes to 0. And the sine of 0 is 0. So we've got our form that signals we need to use L'Hopital, but we need to get it into the right form. Right, this is x times sine of 1 over x. We could rewrite this as the sine of 1 over x divided by 1 over x. Right, because if we were to actually do the division, we would end up back where we started. So these are equivalent forms. And this is the form that we need to apply L'Hopital in. This will be equal to the limit as x approaches infinity of the cosine of 1 over x times the derivative of the inside by the chain rule. So this would be negative x to the negative 2 over negative x to the negative 2. This limit will simplify to the limit as x goes to infinity of the cosine of 1 over x, which is, as x goes to infinity, 1 over x goes to 0. So this is the cosine of 0, which is 1. The trickiest part applying L'Hopital is simply recognizing how can I convert my, if I have say a funny form, into the quotient of two functions. And that just takes practice.